So hello everyone, this is WF7i Homebrew, and I'm starting a new project. I've actually got a couple projects going on, but this is a brand new project I'm going to be working on for a while probably. So the goal is to make a direct conversion receiver that's multi-band. Not really sure how many bands or which bands, probably 80 and 40 for sure, maybe 80, 40, and 20, I don't know. Right now, I am just starting the very, very first stages of it. Um, and I know there's other ways to do tuning, but I like these air variable capacitors. They're just kind of old school, and they have a broad tuning range. And I just wanted to incorporate another radio with an air variable capacitor in it. So that's going to be kind of the foundation of this radio for the tuning. I have a Colpitts oscillator here on the breadboard, so that's a 2N2222 transistor, and a couple of resistors to bias that, and some capacitors in the circuit for the Colpitts that, along with the inductor, give me the resonant frequency that I want, which is around 7 megahertz roughly, very roughly. I'm going to have to do some adjustments to kind of get that tuning range where I want it. This here is a toroidal, toroid here with about 14 turns of wire on it. It's a T50-2. Let's see. I believe it's a T50-2. Any rate, I had a bunch of these toroids in the shack, and I just found one that seemed reasonable. I use them in other radio projects, and there's a calculator on the internet that you can use to actually figure out how long the wire needs to be for a given amount. It tells you how many turns, how much wire you need for a given amount of inductance. And I knew I needed to be somewhere around 1 microhenry, about 1.5, 1.2 microhenry, something like that. So I used the calculator, wound the toroid, and then I checked it here with my little BK Precision LCR meter. Lo and behold, it was about the right value. This here is a really cool little air variable you can get on Amazon for a few dollars. It's kind of an old AM radio type. It goes up to about 350, I think, picofarad, and down to maybe 20 or so picofarad. So it's a pretty wide range. And I'm running this off of 9 volts. And if you want to see kind of the eventual circuit that I'm going to be using, it comes out of Experimental Methods in RF Design. It's an old book from about 20 years ago that I built another radio out of already. And I'm using this circuit here roughly, I mean very roughly. So I'm building this portion here without the NE602 chip yet. I'm just building my own little oscillator. And eventually what I'd like to do is use the transistors inside the NE602 chip to power this oscillator instead of using my own transistor there. And it's really cool, I think, to kind of have that initial moment of oscillation. And that's what you see here on the scope. So right now I've got about, if you can see the frequency here, is about 9 megahertz. So as I rotate the variable capacitor, you can see it goes down to about 5 megahertz. So that's a little bit wider than just the 40 meter band. It's a bit noisy. I can't get it to trigger quite right. I'm not sure why that is, but it's being a little bit, that's a little better. It's been a little flaky. But anyway, it provides a robust signal to drive, to be able to mix. This is going to be kind of the mixer here. NE602 is the mixer. So this is going to be kind of your local oscillator that's going to mix with the incoming signal from the antenna. And the difference frequency is going to be essentially the audio that's going to be then amplified by this LM386. So it's a direct conversion receiver. And what my hope is I will have several, choices of this inductor for different bands. So it'll oscillate down on 80, it'll oscillate up on 20. So what I'm going to do is wind a few more of these coils tonight, probably, or in the next few nights, and see if I can get this thing to oscillate up around 20 meters and down to like 80 meters, and just kind of refine the oscillator to accommodate those different bands. Again, because the frequency span's a little bit broad, I'm probably going to have to put in some networks of capacitors to kind of narrow down the band a little bit so it's not covering like several megahertz, because I want to try to hone in just on the ham bands so that, when you turn this knob here, you're not, it's not like really jumpy. You want it to not have too much frequency change per rotation of that knob. So that's about it. I just wanted to pass that along. It's always kind of exciting to see this oscillation. I've had trouble with Colpitts oscillators in the past. I actually had to use a Hartley last time because I can never ever get this Colpitts to work, and boom, right now it's working right off the bat. So that is really, really encouraging. So that's about it. I'll be posting some more videos along the line here. 7-3.